Okay, here are solutions to 4-4 letter problems. We'll start with letter A. The farmer's market sells apples for $2 per pound and oranges for $1 per pound. Marjorie has $10 to spend. Therefore, we start out with $10 and we subtract 2 times the apples in order to figure out how much we have left to spend for y, the oranges. So the function y equals 10 minus 2x represents the number of apples x and oranges y Marjorie can purchase. Graph the function and interpret the points graphed. So again, we can do this one of two ways. We can come up with an input-output table. We'll do this with x and y. And of course, in the middle, we're going to have 10 minus 2 times y. So if we put in an input of 0, would be a good start. We would have 10 minus, this is actually an x here, doesn't look like it, 10 minus 2 times 0. So that would be 0, so our output would be 10. We could also put in 1. We'd have 10 minus 2 times 1. 10 minus 2, of course, is 8. Put in an input of 2, and we would have 10 minus 2 times 2, or 6. So we can see that we're going to have 10, 8, 6, etc. So we could plot this as 0, 10, and then we're going to move from that point. But I want to point out something here. We can take a look at our equation and change it ever so slightly to negative 2x plus 10, and we recognize that we have a positive 10 for y-intercept, and we're going to have a slope of negative 2, positive 1. So we're going to drop 2. We have to pay very close attention to our scales here. In both cases, we are counting by 2. So we're going to take that into consideration so that because they're the same, we can kind of ignore it, and we're going to drop 2, not 2 on the scale, but 2 grid lines and over 1, and we put a point here. Drop 2 more and to the right 1, and we can put a point there. Now let's take a look at how that lines up with what we did here. We had 1 and 8, so if we move to 1, it goes up to 8. Yes, that looks like that would be a point, but we can confirm that by looking at 2, 6. Go across to 2 and up to 6, and indeed we have a point. So we could take this and put a line on it if we choose to. For some reason my line is not working. But the first thing we need to do is ask ourselves before we put that line there anyway, does it make sense here? In other words, can you have part of a pound of apples or a part of a pound of oranges? And of course you could. So this is continuous data, therefore we need a line. So if we put a point here and go right through all of our points, we'll even go beyond it, and it would match right there. So there's our graph of our line, and now it says to graph the function and interpret the points graphed. Well, interpreting the points graphed, we could take a look at, for example, 2, 6. We could look at this and say that that was 2, this is 6. Right here's our point. We can buy 2 pounds of, and again, they don't label their axes here, so we could go back to this, and our x was number of apples, so this is apples down here. I shouldn't say number of apples, I should say pounds of apples, and this was the oranges over here on the y-axis. So she could buy 2 pounds of apples and 6 pounds of oranges. But you can also recognize that you could go anywhere along this line and say, let's say right here would be 3, so this would probably be 3.5. She could buy 3.5 pounds of apples and then buy what looks to be probably 3 pounds of oranges. You'd have to put these numbers into the actual equation to get exact fractions, but I want you to recognize that she could find any combination, including fractions of pounds of apples and oranges, as long as it added up to that total of $10. Okay, let's take a look at letters B and C. We are being asked to graph this information. Now what we could do here is we could create a function table where we have an input of x, output of y, and our rule for this one is x minus 5. If we put in 0, we have 0 minus 5, we'd have negative 5. If we put in 3, for example, we'd have 0 minus 3, we'd have negative 2. But another way to take a look at this is to remember what we already know. We have a y-intercept of negative 5. So if we put our point, our y-intercept at negative 5, that's 1, 2, 3, 4, 5. We're right here. And now we have a slope of 1 over 1. So we're going to rise 1, run 1, and we're going to keep doing that until we run off of the graph. And that puts us at this point right here. We can get this thing to make a point. And now when we put our arrow on this, it should go right through each corner intersection. We have a nice straight line. Now we can check our values here. We have a point, of course, at 0, negative 5. That's where we placed our intercept. But let's check this one at 3 and negative 2. So we're going to come across to positive 3 on the x-axis and drop down to negative 2. And indeed, that point is on the line. So now let's take a look at our other problem. We have input of x, output of y, and it's negative 2 times x. So we're going to go 0. 0 times negative 2, so that would be negative 2 times 0, I should say, is 0. We're going to have an input of 2, so we have negative 2 times 2 would be negative 4. So there's a couple of points, but again, we can do the same thing. We have y equals negative 2x plus 0, we could say, is our intercept. So we have an intercept at the origin. And now our slope is negative 2 over 1. So we're going to rise negative 2, so move down 2 and over 1, down 2 over 1 would put us right here. We could also do the reverse and put points over here. And now put our graph line on it as closely as we can. And we have this one graphed. One thing I forgot to do is we should label this as y equals negative 2x, and this one as y equals x minus 5. All right, let's look at letter D. A store sells assorted nuts for $5.95 per pound. So right away we ought to think about the fact that this is a unit rate, and therefore it's going to become our slope. It asks us to write a function to represent the total cost of any number of pound of nuts. So we're going to talk in terms of pounds of nuts is going to be our output. So we are going to use P to represent pounds of nuts as our input. So we are going to have 5.95, our slope, times our input of P is going to give us our output, and we'll use C here for cost. And we're going to use 1, 2, 3, 4, and 5 pounds for our inputs. So it's going to be 5.95 times 1, which of course is going to give us an output of 5.95. Now I can do this the easy way and move to our answers. So the one thing I want to point out here that's a little bit confusing here is for some reason they have an input of P, but then they're multiplying by D. I think that's a little confusing, so I'm going to write right over the top of that we're going to multiply by P. So we have pounds times 5.95, 5 and 95 100ths gives us the cost. So 2 pounds costs $11.90, etc. So obviously, since pounds is our input, we're going to use that as our independent variable, our x, our input, and our output then is going to be our dependent variable. It will depend on how many pounds we purchase, and that's going to be our cost. Lastly, we can take each of these points and plot 1 and 5.95, which is going to be about 6 right here, 2 and 11.90, and 3 1785, etc. 1785 100ths, I should say. So first of all, it asked us to write a function. We did that. We have it here. Notice they do use the proper letter here for P. And then they asked us to compare the function table below using 1, 2, 3, 4, and 5 pounds. And then lastly, they asked us to graph it, which we did. And then we have to ask ourselves, is this continuous or discrete data? And it, of course, is continuous because you could buy 5 3/4 pounds, you could buy 5 3/10 pounds, you could buy any amount of pounds of nuts that you would like to, and the output would be the dollar value that you're going to pay would make sense. So it is continuous data, and because it's continuous data, we draw a line representing that data. You can buy any amount of nuts. Please do guided practice.